Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing some results or some questions about limit points of a set. Okay, first question, find all the limit points of the set S is equal to set of all 1 by P plus 1 by Q such that P belongs to N, Q belongs to N. Here supremum of S is equal to 2, infimum of S is equal to 0. How? If you put P equal to 1, Q equal to 1, then the maximum value of this 1 by P plus 1 by Q is 2. And all other members of S are less than or equal to 2. So supremum of S is equal to 2. Similarly, as P tends to infinity, Q tends to infinity, you will get the value 0. Okay, so infimum of S is 0. Here the limit points are as P tends to infinity, Q tends to infinity, you will get one of the limit point is 0. And if you put P is a fixed positive integer and Q varies, then as Q tends to infinity, 1 by P will be the limit. So what will be the derived set then? It is the set of all points containing 0 and all fractions like 1 by P where P belonging to N. Okay, so how? Let us explain. Take P a fixed positive integer and then take Q is equal to 1, 2, 3, 4 and so on. See that in any neighborhood of 1 by P there exists infinite number of elements of S. So for each fixed P, 1 by P will be the limit point. Since P taking here is arbitrary, the set of all fractions like 1 by P will be the set of limit points including 0. Okay. Now additional information, except 0 all other limit points belong to S. Okay. In any case it is not a closed set. What do you mean by closed set? The set containing all its limit point is called a closed set. Here 0 is one of the limit point of S and 0 does not belongs to this set. So this set is not a closed set. Also, the set is not open. Thus, this is an example of a set which is neither open nor closed. Okay. This is one of the point you have to remember. Suppose they have asked the question whether the set is open or closed, then it is the which is neither open nor closed. Next question. Find all the limit points of the set. S is equal to minus 1 to the power m by m plus 1 by n, where m comma n equal to 1, 2, 3 and so on. So let us solve this question case wise. Case 1, m is equal to e. Fixed even positive integer. The points of the set S is equal to 1 by m plus 1, 1 by m plus 1 by 2 and so on, will determine 1 by m as its point of accumulation. Case 2, m a fixed positive odd positive integer. The points of the set S is equal to minus 1 by m plus 1, minus 1 by m plus half and so on, will determine minus 1 by m as its point of accumulation. Case 3, n equal to a fixed positive integer. Then points of the set will be 1 by n minus 1, 1 by n plus half and so on, will determine 1 by n as its points of accumulation. Finally, as m tends to infinity, n tends to infinity, 0 is also a limit point. Therefore, the set of all limit points in this case will be 0, singleton set 0, union, set of all 1 by P, P belongs to n, union, set of all minus 1 by Q, where Q is an odd positive integer. Next, find the derived set of the set of all 1 by m plus 1 by n plus 1 by P, m and P belongs to n. Here also we can solve case wise as in the last problem. Let m be a fixed positive integer, then 1 by m will be the limit point. M and n be the fixed positive integer, then 1 by m plus 1 by n will be the limit point. And as m tends to infinity, n tends to infinity, P tends to infinity, 0 will be the limit point. So the set of all limit points will be singleton set 0 union, one set of all 1 by m, m belongs to n, union, set of all 1 by m plus 1 by n. Next set S is equal to set of all 2 by m plus 3 by n. Here the Here in this case, the limit points will be 0, union set of all 2 by n such that n belongs to n, set of all 3 by m such that m belongs to n. Next, find all the limit points of the set s is equal to minus 1 to the power m plus 1 by n such that m belongs to n, comma n belongs to n. Here as n tends to infinity, here we can divide s as union of two sets, that is set of all minus 1 plus 1 by n. If m is odd, if m is even, then it will be set of all 1 plus 1 by n. As n tends to infinity, the limit points will be minus 1 comma 1. Next, find the limit points of the set of all a plus 1 by n. Here as n tends to infinity, 1 by n tends to 0, so limit point will be e. Okay, thank you friends. Please share and subscribe the channel.